This course is on the harmonic functions on the plane in two variables and the applications. Welcome to the class. This course is organized to teach harmonic functions to the students, of course. And these harmonic functions are very special functions which creates a force field through gradient. And the force field is actually in some sense conservative, namely divergence of that vector field created is zero. And so this special type of harmonic functions should be studied in this course. And throughout the lectures, I talk about mathematical introduction, including the properties of harmonic functions very carefully. And then we'll put much of the effort in creating solutions to the boundary value problem, which means when the boundary values are given on a particular region, then we try to match the boundaries but fill the interior so that interior is a harmonic function. So that's the basic goal of instruction of this course. On the other hand, why do we teach this kind of thing to the students? Because it has much of applications, so many applications to physics, sciences, and engineering. And so we'll actually discuss how to handle some of the basic models, such as modeling electrostatics, and then modeling steady heat and its propagation, and also modeling hydrodynamics in the special simple cases. And so all these things should be handled in this course. But then, of course, this kind of study is not complete. It has to continue, it has to be further developed. But that is out of the scope of this course. And so at the end, I'm going to point out what should be the further studies for students, namely not further studies by mathematicians and scientists, but for students, for continued study, they should learn certain things. Those things will be explained in this course. The second point I'd like to tell you why this course is organized. Usually in many universities and colleges of all over the world, they teach a course named complex analysis or complex variables, in which they teach harmonic functions. So that's very good. On the other hand, they teach so much of function theory of complex analytic functions in the course, and so they do not have enough time at the end to handle harmonic functions. And also, many professors feel like harmonic functions is just a small portion of complex function theory. That way, they get to learn very little about harmonic functions. On the other hand, when they actually become an engineering major, for instance, they realize that they don't know much about harmonic functions. In some extreme cases, professors of engineering ask students, well, I thought you learned some complex analysis from complex analysis course, but how come you don't know anything about harmonic functions, which are most important in this study? Then students are completely betrayed. They feel betrayed. And this is a big problem. And when they try to learn, let's learn about harmonic functions, then usually in mathematics department, course is too much higher in terms of level of teaching. And so there's a big gap in the teaching as far as harmonic function education is concerned. And so this gap has to be at least indicated what has to be studied. And I felt strongly that I have to mention what has to be learned by students. And so this course is organized in such a way that I might actually point out at least what the gaps are, and if it is possible, I want to fill the missing information in their education. I'm not sure how much I could do this, but I give a try. The final point I would like to make is what to know, what to learn before you take this course. This course is designed to be a fourth-year student course, the senior course in college and universities. And so obviously you need to know some mathematics. Our development is based upon 2 complete semesters of calculus. First, usual calculus, differentiation and integration, and then second, vector calculus, namely calculus of multivariables and multi-variable integrals, double and triple integrals. So this course is based upon good knowledge on calculus. Then it is good to know if you know more mathematics, in particular some complex functions, but I'm not going to emphasize that much about it, but this will help. And so the whole course is not going to be self-contained. It cannot be, because I'm teaching only 6 lessons and 6 weeks worth of lessons, so altogether 18. But 3 lectures constitute each week's lesson. And so with this kind of length, there's no way I can cover enough of this thing, because this course has to be at least 1 semester long, full 3-unit course. It has to be. So there's no way I can teach everything, but I'll try to indicate what you have to learn from the books with the references and all. So I hope this thing gives you enough knowledge eventually, and happy harmonic functions for all.